In this video here, we're going to talk about dividing rational expressions, which is a lot like dividing fractions, which if you didn't watch the videos I did on fractions, I did one about dividing fractions, so you might want to check that one out because we're using the same principles here. It's just that our fractions are more complicated because they involve these algebraic expressions. But the way we divide fractions doesn't change whether we have numbers or algebraic expressions. All right, so in order to do this, we go back to what we did with fractions, right? When I have a over b divided by c over d, well, recall, whenever I divide by a number, that's the same as multiplying by its reciprocal, right? 10 divided by 2 is 5, which is the same as 10 times 1/2, also 5, right? Dividing by 2 and multiplying by 1/2 are the same thing. So we never actually divide fractions. We always, instead of dividing the fraction, we multiply by the reciprocal of that second fraction, right? So a over b divided by c over d equals a over b times d over c, right? That first fraction we keep the same, we take the reciprocal or we flip over the second fraction, and then we change the division to multiplication, right? So we multiply by the reciprocal, and then what we do, just like when we multiply fractions, we factor if we can, and then we cancel out the common factors. And I just did a video on multiplying rational expressions, so I mean the problems that we do here are going to turn into ones just like the ones that we did on that multiplying video. That's every division problem with fractions turns into a multiplication problem, right? So if you didn't see that one yet on multiplying the rational expressions, you want to check that out where we did the factoring and the canceling. That's basically where this one is headed, right? So to do a couple examples, we'll do one first with numbers just to remind us how we treat dividing fractions, and then we'll do one where we have those algebraic expressions that we have to deal with, right? And you'll see that we do them the same basic way. All right, so first off, I have 6 over 15 divided by 14 over 25. All right, so remember, I never divide fractions, I change it into a multiplication problem. This is 6 over 15 times 25 over 14. All right, so instead of dividing by the fraction, I multiply by its reciprocal. All right, and now what I want to do is factor and cancel. So all of these fractions here, all of these numbers I have, I want to factor them if I can. All right, so 6, that's 3 times 2, over 15, which is 3 times 5, times 25, which is 5 times 5, and then 14 is 7 times 2. All right, so I factor all those numbers as much as I can here, and then anything in the numerator, any factor that I have in the numerator can cancel out with a common factor in the denominator. So the 3 in this numerator cancels out the 3 in that denominator. The 2 in this numerator cancels out the 2 in this denominator over here. The 5 in this denominator cancels out one of the 5s up in that denominator. Remember, the canceling is a one-to-one thing. So even though I have 2 factors of 5 up here, I only have 1 factor of 5 in my denominators. So that 1 in the denominator only cancels out 1 that's in the numerator. It doesn't cancel out both of them. All right, so what I'm left with then is, well, like almost everything I canceled out. All I have left is a 5 in the numerator and then a 7 in the denominator. All right, so 6 over 15 divided by 14 over 25 equals 5 sevenths. All right, so that's how we treat dividing fractions. We change it to multiplication by taking the reciprocal of that second fraction, flipping it over, and then we factor and we cancel out everything, and then whatever we're left with, that's our answer, and our answer is already simplified because we already canceled out all those common factors. All right, so let's do the same thing here with this algebraic expression. We have x minus 4 over x squared minus 4 divided by x squared minus 3x minus 4 over x squared plus 5x plus 6. It looks a lot more intimidating than the one we just did up here, but remember, we do it the same exact way, right? So first thing I do, I'm dividing things that involve fractions. I don't divide things that involve fractions. I change it to multiplication. X minus 4 over x squared minus 4, that first fraction stays exactly the same. Change my division to multiplication, take the reciprocal of that second fraction. So it's going to be x squared plus 5x plus 6 over x squared minus 3x minus 4. All right, same thing I did here, flipping over that second fraction, changing it to multiplication. I do the same thing. You know, the rules of working with fractions, they don't care if your fractions contain numbers or if they contain algebraic expressions and polynomials. The rules for dealing with fractions are the rules for dealing with fractions. All right, so division, change it to multiplication. And now what I want to do, just like I did up here, is I want to factor everything here that I can factor so that I can cancel stuff out and then give myself a simplified answer without actually having to multiply all this stuff together. All right, so now factoring. All right, so my first thing, x minus 4, I cannot factor that. They have no common factors. The x squared minus 4 here, that's a difference of 2 squares. So that factors into x plus 2, x minus 2. And I'm not going to spend a lot of time here belaboring how to factor these things. If you don't quite understand what I'm doing with the factoring, I would suggest that you go back and look at some of the videos I did on factoring. I did quite a few of them with all the different methods of factoring. So if any stuff here doesn't make any sense as far as how I got x plus 2, x minus 2, go back to the one where I did the special factoring formulas, look at that difference of squares thing to see how that works. All right, the x squared plus 5x plus 6. All right, so trinomial with a 1x squared, so I look for two numbers that multiply to 6 and add up to 5. Those numbers are going to be positive 3 and positive 2. So x plus 3, x plus 2. X squared minus 3x minus 4. Another trinomial with a 1x squared. So I need two numbers that multiply to negative 4 and add up to negative 3. And those numbers are going to be a negative 4 and a positive 1. All right, so when you get good at factoring and you're able to know the different factoring methods and you can kind of put them together fairly quickly, you can see that doing that factoring did not take me a whole lot of time, right? Because I've done so much factoring that I can do it pretty quickly. Many of you maybe cannot do it as quickly as that, but the more you practice it, the quicker it goes. So a problem like this was like, oh my gosh, I have to factor all these different things. Once you get good at it, it's not that big of a deal to just go ahead and do it. All right, I'm just going to real quick, since I did that so quickly, I'm just going to double check to make sure I did it right. That's x plus 2, x minus 2, that's 5x plus 6, that's minus 3x minus 4. Okay, so to double check there, what I did was I just real quickly FOIL this together. X times x is x squared, that's minus 4x plus 1x, that's minus 3x. Negative 4 times 1 is negative 4, just to make sure that I put all those positive and negatives and everything in the right spot. All right, but now that I've got that, I am ready to start canceling stuff out. And this is my favorite part of doing these problems, when I start xing stuff out and getting rid of it, because that just means the answer is going to be that much simpler. So let's see. I have an x minus 4 and an x minus 4. One in the numerator, one in the denominator, so those cancel out. Remember, you can only cancel things out if one's in the numerator and one's in the denominator. Like if I have an x plus 1 down here and another x plus 1 in this denominator, those don't cancel, right? It has to be one on the top and one on the bottom. That's when it cancels out. So what else? We have an x plus 2 and an x plus 2. Those will cancel. And it looks like that's it. Nothing else matches up, right? So in my numerator now, I just have that one factor left, the x plus 3. And in my denominator, I have two factors, an x minus 2 and an x plus 1. So since I have two factors there, I need to keep them both in parentheses, right? When I only have the one factor on the top, I don't need parentheses around that one that's at the top because it's the only thing that's there. I don't need to use the parentheses to set it off from anything else. All right, so that is my final answer for this division. And remember, when we're doing these division problems or the multiplication problems with the rational expressions, we don't actually have to multiply. Like you don't have to do x minus 2 times x plus 1 and multiply all that out. Generally, we want to leave our answers in the factored form, right? So that's what we do. Once we factor it, we just leave them like that. We don't actually multiply them together. All right, so just one more time real quick. For dividing rational expressions, we don't, right? We change it to multiplication. We take that second fraction and we take the reciprocal, we flip it over. Then we factor everything and we cancel out common factors in the numerators and denominators. And then whatever's left gives us our simplified answer, right? That's dividing rational expressions. So it goes back to working with fractions like we've done before. It goes back to multiplying the rational expressions like we did before. All these things tie together. And when you see those connections, it starts to make more sense and it starts to get not so complicated and kind of easier to do. So hopefully I'm doing a good job of showing you what those connections are, how this problem here relates to that problem back there. And if you see that, hopefully it's making sense to you.